Hi everyone, I am Sandhya, Department of Mathematics. Today we are going to discuss about the case study, the conic bridge problem using the matrix representation. So in this conic bridge problem, how we can applying the matrix and graph in the conic bridge problem. So here we want to discuss about briefly. So in this first one is exploring elegant mathematical solution where the linear algebra meets the geometric in the computational geometry and the computer vision applications. So here we want to discuss what is the conic bridge problem in the core challenges and application in the complexity. So first we want to discuss about the core challenges. In this core challenges, intersection points where the two conic section meet in the geometric spaces. Next we want to move on the application. In this application, critical in computer vision for the pattern recognition and the advanced in the geometric modeling system. Next we want to move on the complexity. In this complexity, mainly discuss about the non-linear equation, create the multiple integration point and challenging the degenerating cases. So here we want to discuss about the conic structure and their matrix notation, that is the matrix form. So first we want to discuss about the general equation. For the general equation, so it is discussed about the traditional form. In this traditional form, ax square plus bxy plus cy square and then dx plus ey plus f equal to 0. Here x square coefficient is a and xy coefficient is b and y square coefficient is c and x coefficient is d and y coefficient is e. F is a constant. Okay, next we move on the matrix transformation. In this matrix transformation, elegant representation for this p square transform q into p equal to 0, okay, where the p is denoted by the matrix of xy, the transpose, okay. Next, we move on the matrix structure. In this matrix structure, Q is a symmetric for the 3 times. So here the 3 times means what is the 3 matrix, that is 3 cross 3 matrices encoding all conic coefficient. Next we move on the algebraic power. In this algebraic power enable for the linear algebra tools for the comprehensive conic analysis. So next we move on the why use matrix representation for the conic bridges. Here we want to discuss about the coordinate independence, computational efficiency, degeneracy for the handling. So in this coordinate independence, we have to coordinate system for the complex standard form of the transformation. So in this computational efficiency, what is that dramatically the computation for the poles and critical that is intersection calculations. Next we move on the degeneracy handling. In this degeneracy handling, naturally process for the degenerate conics including pairs of the intersecting lines. So next in this intersection problems, the conic is we have to generally denoted by q1 and q2. So in this q1 and q2 is key innovation and line pairs. So we want to first we want to know what is key points for the conic intersection problems. So in this key innovation, identifying generating the conic with the matrix pencil, that is the lambda. So here we want to line pairs. So first we want to consider what some points for the pair of points, that is a comma b. Similarly, okay, so for example we have to considering a comma b. So in this a comma b generating the conic representation pairs of lines that passes through the intersection points. Next in this matrix pencil and eigenvalue approaches, first we know what is eigenvalue solution. All of you know eigenvalue solution. In this eigenvalue solution, first we want to find the characteristic equation. So for the for example, we want to consider the 2 by 2 matrix. How we can find the characteristic equation? So the characteristic equation is lambda square minus c1 lambda plus c2 equal to 0. We want to find the c1 and c2. This is unknown. We want to find the c1 and c2 value, and then we have to form the characteristic equation. So after finding c1 and c2, we denoting the characteristic equation, and then we want to find the root of this characteristic equation, that is the eigenvalue. Okay, so in this eigenvalue that yield to generate the conic configuration. In this matrix factorization, each generate the conic matrix as the rank 2. So in this rank 2, for the two distinct lines, the distinct means it is a difference line. Okay, so next we want to discuss about the point recovery. In this point recovery, the intersection factorized line with original conic equations. So next we want to discuss about the interpretation and visualization for the geometric representation. Here we want to represent the line representation and visual thing, and one is what is that the approaches. So here we want to discuss about the line representation. In this line representation, usually we want to representing the two pairs of line. We have to conic elegantly represent a pair of the lines that intersecting the original conic for the intersecting points. Next, visual confirmation. In this visual confirmation, what is the that is graphical visualization for the conic and the intersecting line provide the immediate geometric validation of the what is that algebraic solution. So next we move on the approaches. The matrix methodology creates a powerful bridge between the abstract algebraic manipulation and concrete geometric interpretation. So here we want to deal between the what is that algebraic manipulation and the geometric concrete geometric representation. So next we move on the advantage and limitation for the conic bridge problem. So here we want to discuss about the universal method and how we can processing, and then computational. Okay, so here the universal method is the algebraic approaches works across the all conic section types. Next, here the processing is handled generating causes and the complex interaction, that is interaction is nothing but the how we can intersecting the scenario. Next we want to computational easily program for the advanced computational geometry applications. Next we move on the conclusion for the future application. In this conclusion part is powerful foundation and the robotics and computer vision. So in this powerful foundation is nothing but the matrix method provide the what is that it is the tool in a complex conic integration and challenges. In this robotic essential for the path planning and for the detection. So the complex that is what is that complex and the computer vision is the critical for object recognition and the geometric analysis. Thank you.